My name is Oscar Alvarez, and today I'm going to be showing you how to use the code, the Liutex code that is produced by the University of Texas at Arlington. So I'm going to create a folder onto my desktop. I'm just going to call it Liutex, but you can call it whatever you want or put this wherever you want. And in this folder, I'm going to click up here in the search bar, and I'm going to just type in CMD for a command prompt. This is going to open the command prompt in the location of your folder, so in your folder. Now, to get the code, all you have to do is search UTA research, all in one word, and then git. That should bring you to the UTA research GitHub. Now in the GitHub, you're going to scroll down until you find Liutex OA. That is the repository I made for storing all the code for Liutex. Then, if you have not already, please fill out the agreement and email the agreement to either me or Dr. Liu, and get that filled out and signed and sent in to us. Thank you. Then I want the code. I want the Liutex UTA code, so I'm going to HTTPS and copy the Git. So you do have to have Git. So Git clone, and then paste my repository. And now you can see that the Liutex folder is now in my Liutex folder. Now, we're going to get started in testing and showing you how to use the functions. So the first one I'm going to go to is MATLAB, and we're going to I'm going to show you how to use this code, how to use our Liutex code. So here is MATLAB. If you can see the top tabs here, one of them is the Liutex function that I've written for us to use, or for you to use. And then here in this other folder, I show you how to use it. So I'm going to create a new script. What I want to do is find Liutex using my data. So you're going to first loop through your data points. So you're going to loop through your data points, and then for each point, calculate the velocity gradient tensor using velocity. So each point should have velocity, three-dimensional velocity, and this is in 3 dimensions. And we're going to calculate the velocity gradient tensor. So let's say we have some data, and we have produced a velocity gradient tensor. So I'm going to call it the velocity gradient tensor, and it's going to be, I'm going to use the imaginary eigenvalues, because a 3x3 matrix that has imaginary eigenvalues should produce valid Liutex values. Because if this eigenvector, if the velocity gradient tensor has any complex eigenvalues, then it should have Liutex, or produce rotation. So I'm going to go ahead and enter that for -3, 7, 3, 4, 0, 5, 10, 10. Okay, so I have created a matrix, our velocity gradient tensor. And now I want to calculate Liutex. Well, with the function, it's fairly easy. All I have to do is see how it's used, and it is just, I'm just going to copy paste. So copy paste. So I'm going to call the Liutex function, and I'm going to put in my velocity gradient tensor. So for each point, I'm calculating that point's Liutex value, Liutex vector, using its velocity gradient tensor. When I calculate Liutex using this function, it's going to produce this lowercase r, which is the Liutex vector itself, and the Liutex magnitude. Big R. So it'll produce Liutex magnitude big R and little r. And so I'm going to display the Liutex vector R and the Liutex magnitude R, and see what our values are. So I'm going to go ahead and it's going to ask me to save this. Run. I'll say yeah, untitled is fine. And when we look at our command window, our results, we get that the Liutex magnitude for this velocity gradient tensor for this point is 4.67. And here's our vector with the x component first, the y component, and the z component of the Liutex vector. So this is how you use it in MATLAB. So that's the MATLAB code. You just need the liutex.m file.